All right, let's jump right into this explainer. Think of this as your essential, day one orientation as a brand new site apprentice. Now, if you're stepping onto a construction site for the very first time, honestly, the sheer scale of the operation can be pretty overwhelming. But every single massive structure starts the exact same way, literally in the dirt. So today, we're looking at the absolute ground-up fundamentals of site preparation and structural basics to get you totally up to speed.
Here's our quick roadmap for today. We're going to cover 1. Preparing the soil, 2. Laying the concrete blanket, 3. Standard concrete cover depths, and finally, calculating rebar cutting lengths. Let's do this.
Section 1. Preparing the soil. Let's get back to basics. Now, an excavator, or a JCB, is absolutely fantastic for moving massive amounts of earth really quickly. But look at this. Notice how rough and uneven the resulting surface actually is? The machine leaves behind this crater of loose dirt, jagged edges, and just an entirely inconsistent base. As an apprentice, you need to know right out of the gate that you simply cannot pour a level, precision foundation on top of a mess like this.
To build safely, we really have to understand what we've just disrupted. Before excavation, that soil was in what we call an undisturbed state. Basically, that means it had naturally settled over thousands of years, pressing down on itself until it was incredibly dense, solid, and fully capable of bearing serious weight. By tearing into it with a giant steel bucket, we've completely broken that natural compaction. So our first mission as site engineers is to restore a firm, uniform surface at the base of our pit before we even think about bringing in building materials.
So how do we fix all that loose soil? Well, laborers get in there with earth rammers, often called monkey rammers, to thoroughly compact the dirt back into a perfectly uniform surface. Or, if the space is large enough, you might see a mechanical plate compactor used instead. But the goal is exactly the same, manually or mechanically pounding the earth to eliminate all those loose air pockets. They'll strike the ground repeatedly until that jagged, loose dirt literally transforms into a dense, flat, uniform plane that is 100% ready to bear the weight of a building.
Moving right along to Section 2, laying the concrete blanket.
So, the crucial point here is getting the specs right. We're laying down a 75 to 100 millimeter thick layer of M10 grade concrete poured directly onto that newly compacted ground. Now, M10 is a relatively lean mix of concrete, but it's absolutely perfect for this specific job. You aren't pouring a structural column just yet, you're just pouring a leveling course over the earth. But you might be wondering, why go through this whole extra step before laying our steel foundation?
Well, this quote from the site engineering documents provides my absolute favorite analogy for what this plain cement concrete or PCC layer actually does. It says, imagine the PCC layer like a blanket. Most of the times when we sit down, we spread a cloth or a blanket so that no dust gets collected on our clothes or body. I mean, it's just a wonderfully simple way to visualize a pretty complex engineering step, right?
Just like a picnic blanket protects your clothes, this concrete layer ensures the structural rebar we lay down stays totally free from soil, dust, and debris. It creates that final, perfectly level surface that's actually easy to work on. And more importantly, if mud and dust coat your steel rebar, the structural concrete you pour later on won't actually bond to the steel properly. So think of the PCC blanket as your pristine, clean workspace, sitting right at the bottom of a muddy trench.
All right, Section 3, Standard Concrete Cover Depths.
You are absolutely going to want to memorize this chart. Different structural elements require specific minimum layers of protective concrete, ranging anywhere from a 20 millimeter slab cover to a heavy 45 millimeters for a water tank. Cover is simply the distance between the very outside edge of your concrete and the surface of the steel rebar buried safely inside it. This concrete shell is literally what stops the steel from rusting away. Because a water tank is holding immense moisture, it obviously needs a much thicker 45 millimeter cover. A slab inside a dry building? That might only need 20 millimeters. On a site, getting these numbers wrong completely compromises the lifespan of the entire building.
Okay, Section 4, Calculating Rebar Cutting Lengths. Let's get into the math.
We're going to use a standard footing dimension of 2050 millimeters by 1850 millimeters with a depth of 400 millimeters just to anchor our calculations here. As a site engineer or apprentice, you need to figure out exactly how long to cut the straight sections of steel bar for the grid that's going to sit inside this footing. Just follow these simple steps. Always take your total span and subtract the concrete clear cover from both ends to find your straight portion. For a structural footing in the ground, the cover is typically 50 millimeters on each side. So you take the full width of the hole, and you literally just subtract 50 mil for the left side cover and 50 mil for the right side cover. Super easy.
let's actually run the numbers for a footing. You apply the exact same logic whether you're calculating the 1850 shorter span or the 2050 longer span. For the shorter side, 1850 minus 50 equals 1750 millimeters. For the longer side, 2050 minus 50 gives us 1950 millimeters. And boom, that gives you the pure, straight horizontal run of the steel bar.
But hold on, we aren't done just yet. We've got to add the development length. This is an extra 300 millimeters bent at the ends so the bar grips the concrete tightly. You see, steel mesh isn't just laid flat. The ends of the bars are bent upwards into an L or a U shape. This is absolutely critical. Without these hooks, under massive structural stress, the steel bar could simply slip and pull straight out of the concrete. No way do we want that. The development length securely anchors it in place.
So add your straight portion to the two 300mm development lengths, and that gives you your final cutting lengths of 2350mm and 2550mm. You take your straight run and you literally just add a 300mm bend for the left side and a 300mm bend for the right side. These final numbers are the exact measurements you'll hand over to your steel fixers so they can start chopping that rebar.
Once you have the length, you're going to use this formula, dividing the available span by the required spacing to figure out exactly how many steel bars you actually need to cut. You take the available width, divided by the distance required between each bar, which, by the way, your structural engineer will provide, and then you always add 1 to account for the starter bar at the very edge of the grid.
So, everything we just calculated relies entirely on what we started with. Compacting the earth and laying that pristine concrete blanket sets the stage for the whole shebang. The precise strength of your perfectly cut steel means absolutely nothing if you didn't prepare the soil right on day one. So I'll leave you with this. If a building is only as strong as its foundation, is your foundation only as strong as the dirt beneath it?